sir. I am Subhajit Shee from Department of Computer Science and Engineering. Welcome to my presentation. Subject Analog and Digital Electronics. Topic Logic Gate. Brief about my presentation. At first, we see what is logic gate. Then we discuss types of logic gates, their symbol and their truth table. And at the end of this presentation, we discuss about the uses of logic gate. At first, what is logic gate? A logic gate is a device that acts as a building block for digital circuits. They perform basic logic functions. They are fundamental to digital circuit. Most electronic devices we use today will have some form of logic gates in them. For example, logic gates can be used in technologies such as smartphone, tablets, or within memory device. In circuit, logic gates will make decision based on combination of digital signals coming from its input. Most logic gates have two inputs and one output. Logic gates are based on Boolean algebra. It At any given moment, every terminal is in one of the two binary conditions, false or true. False represents 0 and true represents 1. Depending on the type of logic gate being used and the combination of inputs, the binary output will differ. A logic gate can be thought of like a light switch where one position the output is off and another position the output is on. Logic gates are commonly used in integrated circuit. Types of logic gate. There are 7 basic logic gates. Those are AND gate, OR gate, NOT gate, NAND gate, NOR gate, XOR gate, XNOR gate. First logic gate, AND gate. The AND gate is so named because if 0 is called false and if 1 is called true. The gates acts in the same way as the logic and operator. The following instruction and travel show the circuit symbol and logic combination for an AND gate. In the symbol, the input terminals are at left and the output terminal is at right. The output is true when both inputs are true, otherwise the output is false. In other words, the output is on only when both inputs on. Truth table of AND gate. If both inputs are 1, then output will be 1. If one of the input is 0 and another one is 1, then output will be 0, and if both input are 0, then also output will be 0. Move on to the next logic gate. It's OR gate. An OR gate function as a logic or addition operator. A logic OR operation has a high input output 1. A logic gate operation has a high output logic 1 if one or both inputs to the gate are logic high. If neither input is high, a logic low output result. Truth table of a OR gate. If both the input is 0, then output will be 0. If one of the input is 0 and another one is 1, then output will be 1. And if both the input is 1, then also output will be 1. This is the symbol of a logic gate. Here A and B represent the input signal and Y represent the output signal. Move on to the next gate. It's NOT gate. A NOT gate is a simple input and single output gate, also called an inverter. A NOT gate implements logic negation on its input. That is, if the input is true or logic high, then the output will be false or logic 0. Therefore, a false or logic 0 input result in a logic high at the output. Truth table: if input 0, then output 1. If input 1, then output 0. This is the symbol of a logic gate. Here A represent the input terminal and Y represent the output terminal. Move on to the next gate. It's NAND gate. NAND gate is the combination of AND gate and NOR gate. A NAND gate includes one or more inputs with a single output. The NAND gate is symbolized by a figure whose shape matches the NAND gate with a circle followed, often known as a inversion circle. NAND gate, here the symbol is NAND gate. First it is a AND gate, and at the at the output terminal of AND gate there connect a NOT gate, and it's make a whole new gate that's called NAND gate. So table of not NAND gate: input, if both the input is 0, then output will be 1. If one of the input is 0 and another one is 1, then output will be 1. If both of the input is 1, then output will be 0. Move on to the next gate. It's NOR gate. NOR gate is a combination of NOT gate or OR gate and OR gate. No, logic gate, NOR gate symbolize not plus or gate, hence the output of the logic gate is extremely the converse of that of an OR gate. As can we see in the OR gate truth table that the output is 0 only when all inputs of the OR gate are 0. Hence, in the case of NOR gate, the output is logic 1 when all inputs are logic 0. This is the symbol of a NOR gate. Truth table: if both the input is 0, then output will be 1. If otherwise, the output will always be 0. Move on to the next gate. It Move on to the next gate. It XOR gate. XOR or exclusive or XOR gate is yields an output only if two of its inputs are different. That is, if one of them is active high and other is active low, then the output will be active high, otherwise low. The plus sign within the circle is used as a boolean expression of the XOR gate. To table of XOR gate: if both the input is 0, then output will be 0. If one output is 0 and another is 1, then the output will be 1. If both the output is 1, then if both the input is 1, then the output will be 0. This is the symbol of a XOR gate. Move on to the next gate. It's XNOR gate, and it's the last gate, last basic logic gate. The XNOR gate is built by connecting the exclusive OR gate and the NOT gate. It is also called XNOR or XNOR gate. The output of the XNOR gate is logic high when both of the inputs are 1 or logic high, and if both the inputs are 0 or logic low. The states that both the inputs should be equal for the output to be logic high or 1. XNOR gate. This is the basic symbol of a XNOR gate. It's basically the XOR gate. At the output terminal of XOR gate, they connect a NOT gate. Truth table. Let's see the truth table of XNOR gate. If both the input is 0, then output will be 1. If one of the input is 0 and another one is 1, then output will be 0. If both of the input is 1, then the output will be 1. Let's see the uses of a logic gate. A digital circuit is building blocks of logic gates which perform a partial of basic logic gates that are necessary by any digital circuit. This can be accept multiple outputs and yet only output one. The output of a logic gate is determined by the combination of inputs across it. The carry output logic process logic gates make use of Boolean algebra. Nearly every digital device we use on a daily basis contains logic gates. In the architecture of our laptops, phones, memory device, and tablets is logic gate. Logic gates are used in various gadgets that we use in a daily basis. Mm, This is the basic uses of a logic gate. We move on to our we move on in the last of our presentation. Thank you, sir.